Welcome back. Let's talk about the types of databases that exist. Now, here's the thing. The world of databases is extremely complicated. There's so many databases out there, so many new innovations, different databases for different things. It's impossible to know all of them. So we're just going to do a brief overview of what exists and why we have so many databases. So let's start off with the first one. Why do we have so many databases? I mean, look at this little diagram that I found. That is a lot. Well, because we have different needs with data, different databases are good at different things. So there's many different databases because we need them from different solutions. But the first thing we need to talk about when talking about databases is this idea. There's three main categories of databases. Now remember, databases are just computers. They're computers with a hard drive, essentially. Just like your computers is able to store files and have files available anytime, that's what a database is. Every time you turn off your computer and turn it back on, you expect your files to be there. And a database is that. You expect that your data persists. That is, the data that you save, whether we turn off the computer or turn it back on, it's still going to be there, and then we can access it, we can modify it. That's the role of a database. And we have three main types. One was the original type of database, which was relational database. A relational database is a database like Postgres or MySQL that allow you to use SQL to make transactions. That is, to write to the database, to read to the database using the SQL language. Now, relational databases were all great until around 2000s, when initially we just had one database, one master database that held all the information that we needed. But starting in the 2000s, we got more and more data. We collected more and more data, and all of a sudden, all that information cannot be stored on just one database. So we had an issue. We now needed two databases to hold that information. And although I'm simplifying things, the idea was that now because we need distributed databases, that is, we needed more than one database to store all that data, relational databases didn't have the necessary tools to have this idea of multiple databases working together. So NoSQL databases were born out of that. Databases like MongoDB became popular because for the first time, it allowed us to do distributed databases. That is, we can have different machines, 10, 15 machines, all working together as one database. Finally, more recently, we have this idea of a new SQL database. What does that mean? Well, new SQL databases are still fairly new, but they try to get the best of both worlds. You see, relational databases are really, really good for something called ACID transactions. They have some really nice guarantees when we read and write data to make sure that it's always accurate. NoSQL databases were a little bit more disorganized, but it allows us to store information on distributed databases. That is, as our data gets bigger and bigger, we can have a NoSQL database on different machines so that it scales up with our data. New SQL databases like VaultDB or CockroachDB are trying to have the distributed nature of NoSQL databases so we can scale up our data, but also have some of the guarantees of relational databases. Now, these new SQLs are still in the works, but definitely keep an eye on them. Another way to talk about databases is using databases for their own specific needs. For example, there's some data storage or databases that are specifically used for searches. For example, Elasticsearch or Solr are used as searching databases. So we put data in there and it allows us to search for things really fast. Then we have things like computational databases. Something like Apache Spark that allows us to use the data that we have in the database and make computations and calculations on them. And we'll get to Apache Spark shortly. Finally, I just want to introduce you these terms that you might hear when it comes to data engineering. OLTP and OLAP. You can think of OLTP databases as relational databases or SQL databases that allows us to make transactions. For example, if you have a web app and that web app has a user that you can store user information, you can upload photos and have that application interact with a database for a user, that's OLTP databases. An OLAP database is usually used for analytical purposes. Now, I'll leave some resources if you want to really dive deep into this topic. But as you can see, there's many ways to describe databases. We have many different types of databases, but at the end of the day, each database is good for its own specific use. If we look back at our diagram, databases are used everywhere. For example, these streams, these are usually OLTP databases, like relational databases that collect information. Let's say a user on a mobile phone updates their username. Well, that goes to a relational database, an OLTP database. And then a data lake. Well, a data lake is another database, usually something like Hadoop, which we're going to talk about. And then that data goes into a data warehouse. All of these things that we see here are essentially databases. We collect information from different streams. We have data lakes, which are databases, and data warehouses, which are databases. So over the next couple of videos, knowing what we know about databases and how we have different types of databases, let's try and figure out how this whole picture of a data engineer works.